We start by recalling that cos of pi upon 2 minus an angle is equal to sine of that angle. Therefore, cos of pi upon 2 minus sine inverse x is equal to sine of sine inverse x, which in turn is equal to x. Therefore, cos inverse x is equal to pi upon 2 minus sine inverse x. Replacing x with 2x upon 1 plus x square, we get the result cos inverse 2x upon 1 plus x square is equal to pi upon 2 minus sine inverse of 2x upon 1 plus x square. Using this result, the given integral, let's denote it by I, can be written as integral from minus 1 upon root 3 to plus 1 upon root 3 x raised to the power 4 divided by 1 minus x raised to the power 4 times in brackets pi upon 2 minus sine inverse of 2x upon 1 plus x square. This integral can be broken into two components. The first component is equal to pi upon 2 times integral of x raised to the power 4 dx upon 1 minus x raised to the power 4 between the limits minus 1 upon root 3 to plus 1 upon root 3. And the second component is minus integral 1 upon root 3 to 1 upon root 3 x raised to the power 4 upon 1 minus x raised to the power 4 times sine inverse of 2x upon 1 plus x square dx. Now let's denote the integrand of the first integral by fx. And let's denote the integrand of the second integral by gx. Now note that f of minus x is equal to minus x raised to the power 4 divided by 1 minus of minus x raised to the power 4, which is equal to x raised to the power 4 divided by 1 minus x raised to the power 4, which is equal to fx. In other words, fx is an even function. And so using properties of definite integrals, the value of the integral from minus 1 upon root 3 to plus 1 upon root 3 of fx dx is equal to 2 times integral 0 to 1 upon root 3 fx dx. Similarly, note that g of minus x is equal to minus x raised to the power 4 divided by 1 minus x raised to the power 4 times sine inverse of minus 2x divided by 1 plus minus x whole square. This is equal to x raised to the power 4 divided by 1 minus x raised to the power 4 times sine inverse minus 2x upon 1 plus x square. And this is equal to minus x raised to the power 4 divided by 1 minus x raised to the power 4 times sine inverse 2x upon 1 plus x square, which is equal to minus gx. Therefore, gx is an odd function. And therefore, using properties of definite integral, integral minus 1 upon root 3 to plus 1 upon root 3 gx dx is equal to 0. Therefore, the given integral I simplifies to pi upon 2 times integral 0 to 1 upon root 3 fx dx, and fx is equal to x raised to the power 4 divided by 1 minus x raised to the power 4. This can be rewritten as minus pi times integral 0 to 1 upon root 3 minus x raised to the power 4 dx divided by 1 minus x raised to the power 4. Now in the numerator, add and subtract 1, and therefore this can be written as minus pi times integral 0 to 1 upon root 3, and the integrand is 1 minus 1 upon 1 minus x raised to the power 4 dx. This breaks into two components. The first component is minus pi times integral 0 to 1 upon root 3 dx, and the second component is plus pi times integral 0 to 1 upon root 3 dx upon 1 minus x raised to the power 4. Now 1 minus x raised to the power 4 can be written as 1 minus x square times 1 plus x square, and therefore I is equal to minus pi upon root 3 plus pi times integral 0 to 1 upon root 3, and the integrand can be expressed as half of, in brackets, 1 upon 1 minus x square plus 1 upon 1 plus x square dx. This is equal to minus pi upon root 3 plus pi upon 2 times integral 0 to 1 upon root 3 dx upon 1 minus x square plus pi upon 2 times integral 0 to 1 upon root 3 dx upon 1 plus x square. Now 1 upon 1 minus x square can again be expressed as half of, in brackets, 1 upon 1 minus x plus 1 upon 1 plus x. An integral of 1 upon 1 plus x square is equal to tan inverse x. Therefore, the value of I is equal to minus pi upon root 3 plus pi upon 4 times, in brackets, ln of 1 plus x minus ln of 1 minus x between the limits 0 and 1 upon root 3 plus pi upon 2 times tan inverse 1 upon root 3, which is equal to pi upon 6. Therefore, the value of I is equal to pi square upon 12 minus pi upon root 3 plus pi upon 4 times ln of 1 plus x upon 1 minus x, with the limits of x being 0 to 1 upon root 3. This is equal to pi square upon 12 minus pi upon root 3 plus pi upon 4 times ln of 1 plus 1 upon root 3 divided by 1 minus 1 upon root 3 minus ln of 1 upon 1. Now ln of 1 is equal to 0 and ln of 1 plus 1 upon root 3 divided by 1 minus 1 upon root 3 simplifies to ln of root 3 plus 1 divided by root 3 minus 1. I multiply the term within the ln with the conjugate of the denominator, which is root 3 plus 1, and divide by root 3 plus 1 as well. And therefore this term is equal to ln of root 3 plus 1 whole square, which is equal to 3 plus 1 plus 2 root 3, divided by root 3 minus 1 times root 3 plus 1, which is equal to 3 minus 1. And this simplifies to ln of 4 plus 2 root 3 divided by 2, which is equal to ln of 2 plus root 3. Therefore, the value of I finally simplifies to pi square upon 12 minus pi upon root 3 plus pi upon 4 times ln of 2 plus root 3. This is equal to pi upon 12 times, in brackets, pi minus 4 root 3 plus 3 times ln of 2 plus root 3. And this is the required answer.